Welcome to all. Now this is class number. This I am announcing in every class because these classes are meant for the RCC batch I am running. So they should not get confused. But these things I also upload in YouTube so that general public can benefit. It is class number 20C for regular RCC batch, and for general public it is a part 8. I remember it is part 8. Okay, anyway, if any mistake is there, you can see in the thumbnail there what part is written. Okay, now part 7 I uploaded little earlier. That is only concept based. Only for those who want to understand can go through it. So otherwise, skip that class. After part 6, come to part 8. Now, analysis of doubly reinforced. I forgot right there, one extra you have to add. Okay, add it. Doubly reinforced, okay. Rectangular sections by working stress method. Roman 2. Roman 1 is to find stresses developed when the given cross section is subjected to a bending moment M. I told left hand side M, right hand side whatever stresses are developed. Roman 2 is to find moment of resistance. Every class I show, see, when I tell stresses developed, this is the last time I am telling, see, randomly apply bending moment. But when I want moment of resistance, see, I always tell moment of resistance. Yes, capacity. So here, remember, permissible stress will come. I will write later. So under reinforced, over reinforced, balanced, all will come here. Okay, one by one will come. Anyway, in class, earlier class, I think class part number, little earlier part, see, when I started WA reinforced section, today is 7, I think 6, most probably, I have given procedure for both finding stresses and how to find MR. Go through it once again. Or singly reinforced section, I thoroughly told it. Calculation of MR for given cross section. The word given is important. Okay, start. Question dictated in class. Now, I made a slight change. I will tell you right now only. Usually I talk little fast outside. Even in my offline class also I talk fast. People understand after 1 or 2 classes. But online classes, after going through the recordings, I found maybe my speed is slightly more. Therefore, I decided to go little slowly. And one more important announcement is going to come regarding my future plans. It's a very huge plan, and it is education for all. Complete structural education, I will start in YouTube. Details, I will upload I don't want to call a video, but okay, people can call video. I will upload a class. I won't call it a class. Some information speech, something like that. Okay. Now, question dictated in class. Write the question. I will do one thing. Usually when I dictate question, sometimes I come here and explain. The rhythm is gone. So I will only dictate. I will just look at the question and tell the question, write it. A rectangular section of a RC beam, 250 millimeter wide and 600 millimeter is 250 millimeter wide and 600 millimeter deep, full stop. It is reinforced on tension side by 3 bars of 16 mm diameter at a clear cover of 45 millimeter and on compression side by 2 bars of 12 mm diameter at a clear cover of 40 millimeter. Taking M25 concrete and tar steel of grade Fe415, find moment of resistance of the given cross section. Okay, start. 250, see, these waves means what? Space problem here. Those who are serious, they want to correctly understand. See, you write repeatedly for each problem. You are not losing. Once you make a fair copy for each question, later when you refer, everything will be clear. If you start writing this way all, for me it is okay. I am not learning from these classes. Breadth of the beam or width, B, 250 millimeter. See the cross section in millimeter. D, now before that one thing forgotten in the question, suppose it is not given, we assume it. Okay, this time we'll assume. We'll assume that, you write here, BM is going to be sagging, your choice. So therefore, compression at the top, tension at the bottom. So this is extreme compression edge. So your limit state method. Yesterday I started limit state method. That's why suddenly XU came. So X, D, D dash, all are measured from extreme compression edge. Make a note. Or you can do one thing. Suppose it is given hogging BM. Next question, when I do Roman 2, see, this is Roman 2, A. One more question is there. Why one more question? One more question because one question for under reinforced and one question for over reinforced. Okay, so this is A. I have set the question for under reinforced. See, if you can see, somewhere corner, I made a note. You may see or may not see it. Why? Because if I keep on calculating in the class, it will take a lot of time. Time waste it is called. Offline classes, I never do it. I always solve only bringing a pen, that's all. But these classes, I cannot keep a paper with me. It is against my rules. It's impossible to imagine me taking a class with a written paper. But time counts. So what I done is, before the class, I will write. This I will do it. But as much as possible, I will try to write here only. See, that's why today, usually I write the X value, etc. Today I decided not to write. Okay, because values are there. This sequence I will continue in future also. Unless there's a question which is very vast, then I may write something before the class. Okay, next. So sagging BM, effective depth D, 600 minus 45 minus 16 by 2, 547. Area of steel in tension, AST, I should not explain, calculate. Area of steel in compression, calculate. Effective cover to compression steel, D dash. See, from here to center of steel, 40 plus half of 12 is 46 millimeter. Further data, concrete given M25. You write here, given. Arrow mark means I am dictating, you have to write. Given, concrete, M25. For which, not arrow mark, for which, as per IS code, sigma CBC, permissible stress in bending compression is 8.5 Newton per mm square. Steel given is tar of grade Fe415. IS code will tell sigma ST 230 Newton per mm square. Means you find the moment. Now, required to find, see, green color. Green is good. This time we are careful. Like this time we will eat some restaurant, keeping in mind how much money we have got. We won't overeat and pay the penalty. We will see our capacity. Required to find moment of resistance of given cross section, so that what? Stress in concrete at any cost, extreme compression side should not exceed 8.5 Newton per mm square, and stress in tension steel should never exceed 230 Newton per mm square. But depending upon under reinforced, over reinforced, one of them will not reach the limit. You should see what? Which will first reach the limit. This all I told earlier. Okay, start. Location of neutral axis. That is how to find X. Let X be depth of neutral axis from extreme compression edge. We have for a doubly reinforced rectangular section, equation to locate neutral axis is, I write the equation now, X I will put blue color. The equation is, okay. See, for writing equation, I have not written any equation there. I don't have anything here. Then how I write? I am actually deriving it. Every time I want equation, mentally I derive and write. Or if you want, moment of the compression area in terms of equivalent concrete about neutral axis equal to moment of equivalent tension area or moment of tension area in terms of equivalent concrete about neutral axis. That's all. Okay, right. Equation is B into x is blue color because neutral axis. Bx square by 2 if the color is visible for you. Sometime in the YouTube because of quality, color may not be visible. No problem. Bx square by 2 plus MC minus 1 into ASC into x minus d dash equal to m times AST into d minus x. This is the equation for neutral axis. Okay, now start. Before substituting problem, why? M and MC are required. First write, as per IS code, modular ratio M, which is to be applied to tension steel, this I told earlier, you can see here, equal to 280 by 3 times sigma CBC. You can write 280 is in Newton per mm square, sigma CBC also should be Newton per mm square, write it, equal to, it is unitless, 280 divided by 3 divided by 8.5. I know this answer because it's a popular number, 10.98. Okay, we got M. Then write, again as per IS code, modular ratio on compression side, MC, equal to 1.5 times M equal to 1.5 times 10.98. This value I don't remember now, I will calculate, no problem. $16.47. Okay. 16.47. I think my speed is okay, I think now. Okay, now I will write here, substituting in equation for neutral axis. See now, substitute. B, 250 into x square by 2 plus MC minus 1, 16.47. Actually, I can write 15.47. No, correct means correct writing into ASC, 226.19.19 MC minus 1 ASC into ASC into x. I am not seeing the equation. Why? Because I am deriving once again. X minus d dash 46 equal to M 10.98 into AST 603.19. Space problem is there. I don't know. I write here because I don't know up to that into bracket 6, not 6, 5. Okay. Into bracket 547 minus x is the equation. Just 1 minute. I will just check the camera because I do not want anything to go out of the camera. Sometimes rarely it happens. Okay, no problem. Everything is within the camera range. Okay, now, I told you, solve this quadratic equation and get the value of x. No one should tell those who attend my class, sir, explain how to solve quadratic equation. It is actually insult for engineering student or engineer not to know how to solve quadratic equation. Okay. I noted down the answer, 138.143 millimeter. Okay, now what I am doing is, I am writing x we got. Now, MR equation. I write MR equation. See. Now, color changes. Now, one small note. If you want, you write here, note. I will dictate here, you write. Color will come. This is calculation of MR. Therefore, capacity. Therefore, here, balance section, under reinforced section, over reinforced section, and then color, permissible stress, all will come. You write that note only in a box. Okay, start now. First, I'll do one thing. Now make a note. If singly reinforced section, we can write equation for MR or expression for MR either in terms of compression or in terms of tension. Just replace M by MR, right hand side, right, permissible stress, that's all. W reinforced section, expression for M in terms of compression is simplified. You know it already. But do not tell it is not possible to write in terms of tension. It is possible, but you know the struggling. If you see class number 8, I uploaded around 2 hours earlier. I am recording now only. A little earlier, you can see there how much struggling you have to make. Locate the resultant line of action, etc. So that is not required. But I showed that calculation only one purpose. Nothing is impossible for, or I will tell sometime for me, structural engineering. Or if mathematical part, or see this line of action of resultant all comes from engineering mechanics, etc. So engineering mechanics, strength of material, structural analysis, matrix method, etc., etc. I will never make one single mistake. Why? Because pure mathematical. RCC and steel or pre-stress concrete, there are so many approximations. So therefore, I will not make mistake. Some design, when you design, result may slightly change among people. But structural analysis or engineering mechanics, strength of materials or structural analysis or my most favorite matrix method, if I tell answer should be this much, what I can do is I can bet my life on it. It is that much only. If I tell that way, if someone tells wrong, I will never agree because mistakes will not come. But procedure, etc. But calculation when I do, or I will tell only possibility is calculation mistake. That's all. Technical mistake will not be there. So now therefore write all these things and write W input section. You write here, it is better MR based on compression. Write that much. No, start. We have for a doubly reinforced rectangular section, you should write not drifts like that. Doubly reinforced rectangular section, moment of resistance MR equal to, right here, first write moment of resistance, that is MR, equal to B into X is blue color. I think this color problem will come now. Slowly color problem. Okay. B into X. This color problem sometimes is so horrible. I find difficulty to manage it. Once I write in a color, it goes to other color then. Okay. BX into, now see, I am changing it. Whenever you find MR, you should write one thing. Now the stresses you are going to write is maximum permissible stress for that cross section. So BX into, the color is green, FCBC max permissible, that's all, divided by 2 into D minus, once again, X by 3, incomplete, plus can I write here? Plus MC minus 1 into ASC into FC dash into D minus D dash is the equation. Checking there, as usual. Risk factor is there, no? That's why. I do not want. Okay, no problem. Over. Now, see, this is FC max. One by one you have to get it now. See here. B is known. X is known. 2 is known, everybody. D is known. X known. MC known. AC known. Everything is known. Now you require, you make a note here. You write a note. Now to find moment of resistance, we require FCBC max permissible and also FC dash. That you require. So right there. First, now to get FCBC max permissible. That is what? Maximum permissible compressive stress in concrete, of course understood, in bending compression, I won't waste time, in concrete for very, very important given cross section. Why given cross section? Because it depends upon whether section is under reinforced or reinforced. Start. Now I will not waste time. Now write here. Now write, to get FCBC max permissible, you make a note here, red color. First we have to check whether cross section is under reinforced or over reinforced. For that, find the depth of neutral axis for a balanced section. Right. We have depth of neutral axis for a balanced section. See red color. For a balanced section, that is called XC equal to K into D. D is usual black color. Why? It's a depth into K into D. Now one by one, where K is neutral axis constant for a balanced section. Okay, start. You know the formula. We have K equal to, the formula for K is black color only, 280 by 3 divided by 280 by 3 plus sigma st. This already told for you earlier. Okay, now substituting equal to 280 by 3. People write different languages here, but whatever way they write, finally answer is same. Sigma st is 230. It will come 0.289 because I know this number from more than 20 years. 0.289. Okay. Now substituting XC equal to 0.28, red color. Okay, actually not required. 0.289 into D. D is 547. You can comment in the comment box whether my speed I am going to tell today is okay or do you want any changes. So I should know it. At least comment. See, I am doing all these for your benefit. And the future courses I will explain to you little later. Okay. So you should comment. People don't usually comment. Even if you give negative comment also, I don't bother. Because I know what is my worth. 158, it is already there. I calculate 158.083. Okay. But calculate 158.083. 158.083 millimeter. Okay, now what you do is, see, this is 1 minute here. I'll tick here because this is separate. Okay, now compare your X, whatever you got, with the XC. Therefore, X is blue color. Color problem once again. Okay. Therefore, X is less than XC. See, I always take care. See here, I write once again, X we got. These all not required. This is to give more important to understanding purpose. Where is X? 138.143. Your XC, just now you got. XC, just now you got red color value is here only. Okay, here only. XC. Right. Therefore, cross section is, X is lesser. It is under reinforced. All of you, please comment there. Whether the speed I am going to change, is it good or you want my old speed? So I can make out. If you actually this is a learning process for me. I usually talk fast. Now slowly I am changing my pattern so that I do not want the speed to be an issue. Okay, now cross section and right point. Now what happens is you have to continue. See, later, next class, part number 10, I will take Roman 2b. Same type of question, but I will see that cross section becomes over reinforced. Therefore, To save the time for that one, I will not rub any of this one. I will change the numbers only. Therefore, but this will change. Data will change. Therefore, I will only rub this portion now. This I will not remove because this portion will next time when I go for second question, this will change. So that I can change now. This I have to write once again. So this is of no use for me. This I have to write once again. Heading also I will not change. Okay, see. Required point MR also not required. Okay, that I will write once again, no problem. Values I know it. Now I will complete the question in this area only. In this space is sufficient for me. Okay, this is also not required. Okay, start. I will continue. Cross section is under input. So little I will write here now. I told so many times under reinforced section means you should write, if those who want, write here. All the statement right here. Under reinforced means area of steel provided is less than that for balance section. So as you increase the bending, stress in steel, tension steel will first reach the permissible limit. Therefore, maximum permissible stress in tension steel, that is FST max permissible equal to sigma ST equal to 230 Newton per mm square. Just a minute. I came down very much in the board. Okay, done. But remember, right here, but FCBC max permissible is less than sigma CBC. Very, very important. Stress in concrete in compression cannot reach the limit. I think I will slightly shift the camera so that, okay. Slightly shift the camera so that you can see that one. Okay, done. So it is lesser. Write that statement. Now, again, when I move here, if a little camera is pulled, it will lose the range. Here, lady. Okay. Now, right. But see, right, this much over. So maximum permissible stress in steel is 230 sigma ST. But permissible stress in concrete is less than sigma CBC. But we want stress in concrete. This we do not want because, make a note, if you want to use this sigma FST equal to sigma ST, you have to use the equation for tension, equation for MR in terms of tension. You know problem, how lengthy it is. You have to locate line of action of resultant compression force. So much work is there. Therefore, we always want FCBC max permissible. Therefore, to get FCBC max permissible, what to do? I told, use, or you can make a note here, FCBC max permissible is that value or that stress which concrete will reach when the stress in steel reaches sigma ST equal to 230. Write a statement, good for health. Or, you write the statement, maximum permissible stress in concrete is that value, that particular value when stress in steel reaches its limit. Surely that value is less than sigma CBC. By chance, if you use stress in concrete equal to sigma CBC of 8.5 Newton per mm square, then stress in steel will go beyond the limit, unsafe. So here write. So to get maximum, get FCBC max permissible, use the relation MFCBC divided by FST equal to X divided by D minus X. Substitute FST equal to sigma ST or FST, substitute FST equal to FST max permissible, that is equal to sigma ST equal to, in this question, 230 Newton per mm square. I'll write here, substituting M 10.98 into our important, I'll put here, FCBC divided by 230 equal to X, Now I am not using color now. 138.143 divided by, oh, D is 547, I think. Yes, correct. 547 minus X, 138.143. This will give me what? This will give me FCBC max permissible for given underline post section, for given section right here, which is found to be under reinforced, equal to 0.078 Newton per mm square. Therefore, I got FCBC. Now I require FC dash. Okay, last one now. See, this over. To get FC dash, that is compressive stress in concrete, not steel, but where? At the level of centroid of, write ASC, okay, to save the time. Don't write ASC. At the centroid of compression steel. Okay, for that one, right here, consider compressive stress diagram. Upper side now, because sagging beam. This is your FCBC. This FCBC, already you calculated how much? 7 point, let it be FCBC only. Sometimes some words I use Kannada because it is a mother tongue language. This is your X, neutral axis. This is your FC dash. This is D dash. This is X minus D dash, right? FC dash equal to, now do one thing, first write similar triangles, FC dash divided by X minus D dash equal to FCBC divided by X, no space to write here, you write that one. FC dash divided by X minus D dash equal to FCBC by X, I already told you, equal to FCBC into X minus D dash divided by X. Now, substitute right here, substitute FCBC equal to how much? 7.078. You get 7.078 into 138.143 minus 46, correct? 46? Yes, correct. Divide by 138.143, your FC dash will come 4.721 Newton per mm square. This is the stress right here. This is the stress. You should write. This is there is some important concept now. This is the compressive stress in concrete at the level of centroid of compression steel. Now, just for information, there is an IS code condition. They told that if you want, you can write. It is always satisfied. So many people will not use it. They told stress in compression steel, should not exceed sigma SC as per IS code. You see, search IS code. In the table it is there. See, sigma ST is stress in tension steel. Sigma SC is stress in compression steel. It should not exceed. It will never exceed, my guarantee. Right here. How to verify? Now see here. How to verify is when the sigma SC for Fe415 steel is, see the IS code. Actually, IS code is here. Here, I don't require. You search the table. You can see there. Compression in steel is 190 Newton per mm square. Okay, now, right here. How to verify it now? They told stress in compression steel. Some will tell, okay, sir, 4.721 is in concrete. Right here. When FC dash, right there, stress in compression concrete is 4.721 Newton per mm square, then stress in compression steel equal to MC times FC dash, no minus 1 now, equal to MC is No minus 1, 16, LMC, 16.47. 16.47 into 4.721, it will come 77.755. 77.755 Newton per mm square. Compression steel will get this much stress, no problem. It is less than the permissible limit sigma SC of 190 Newton per mm square. Therefore, safe. Okay. Actually, this statement nobody writes because it always comes much, much lesser. It is not required to verify, first of all. But still, technically you require. So, those who find difficulty, you can do one thing. This you can skip. Okay, now, last step, where I should do? I will do one thing now. See, now last step I will do here. Okay, here I will do. Last step, because space problem. Okay, don't see anything else. Last step, over. Substituting MR equal to B 250 into X 138.143 into FCBC max permissible 7.078 divided by 2 into 547 into 547, correct, D is 547. Because I rubbed it out, I think it is 547, I think. 600 minus 45 plus 540, most probably 547. Anywhere is there? See, sometimes number should not, 547, yes, 547 minus X 138.143 divided by 3, space problem, plus MC minus 1. I'll put here now, plus further, plus MC minus 1, 16.47, minus 1, okay, sorry, minus 1, ASC 226.19, 226, because I know that area, 19, MC minus 1 ASC into FC dash 4.721 into bracket D 547 minus D dash is 46. Your answer will be 69.50 10 to the power 6 Newton millimeter. That is 69.50 kilonewton meter. Okay, over. This class over. Now what I will do is, tomorrow, this already now it is around 12 o'clock now. Tomorrow, 12 o'clock night, tomorrow I will record for Roman 2B WA in post section. At that time, these all I will not explain once again. So I will not rub this one. I will maintain all this. But one thing happens tomorrow, it will come overrain post. You are happy because if it is overrain post, maximum permissible FCBC, sigma CBC, but IS code problem is there. Okay, I will take that one in the next class, not tomorrow, next class. Okay, thank you. Go through the class. Anyway, in the comment box, write what speed I told today, because I should know. See, when I have got a huge plan, mega plan of giving structure engineering knowledge, I will tell throughout the world, one systematic way, everything will be told. So I should have I should know whether my speed, what I told now is okay, or you can give suggestions. What, if you feel, if I suddenly go fast somewhere, you can tell, sir, you suddenly, when you tell this one, you go fast like that. If you feel okay, I should get used to it first of all. See, now suddenly I am changing the pattern. Another 2 or 3 classes, see, I will get used to it. Slowly, it is possible, I know it. When every day you talk same way, you get used to it. Suddenly from high speed to low speed, difficult, transition period. So, please comment and let me know. Okay, thank you. We will see in the next class, that is part 9, where we will cover WA in post section, which will come over rain post.